Hi everyone, Dr. J here, and in this video I'm going to give you an introduction to the Pandas Python package. Pandas is a column-oriented data analysis API, as it shows here. Great tool for handling and analyzing input data that's organized in columns, which is typical of lots of spreadsheets. So Pandas is really kind of an equivalent of a spreadsheet program in Python. And please do refer to the Pandas documentation site for more examples and concepts. Alright, so let's start with basic concepts. We're going to go ahead and run this cell. Okay, so the fundamental types of data in Pandas are data frames and series. And a series is just a single column, and a data frame contains one or more series and a name for each of the series. So again, just thinking in terms of equivalent to a spreadsheet, a series is just a column in the spreadsheet, and a whole data frame is just the name for the whole entire object, which is similar to a spreadsheet. And let me just go back here and emphasize, import pandas as PD is a very standard way to import this package. So again, it's a package that has to be imported. It's not part of the standard library. And the fact that it's not part of the standard library also means that it has to be installed if you're not using Google Colab. So if you're trying to run these programs on your local computer, just keep in mind that you'll need to have pandas installed. If you say, import pandas as PD, and you get an error, no module named pandas, that means that you need to install it on your local machine. So when we're calling the methods and functions that are in this module, we can use this pd dot syntax where we say pd dot and then the function or the method that we're going to use. All right, so we can construct a series object, and probably the simplest way is to reference it like this, where we pass the series method a list of names. So we can create a data frame object also by passing a dict, mapping string column names to their respective series. So here we have a series of city names, and we can create a variable called city names and assign that series to that variable. We can create another variable called population, again creating a series, and then we can concatenate those two series or two columns into a single data frame or a single spreadsheet equivalent using a dictionary. So we have city name and then our series of city names, population, with our list of our series of populations. Notice that this is a dictionary, so we have these curly brackets on either side, and we have the name as a string of each key. So these strings here are the keys of the dictionary. We have the colon there, and then we have the series of city names and population, which is our values. That dictionary, so let me just go ahead and pull this out for a second. All right, so we've created these two series. We've created the city names and population series, and now we're just printing out a dictionary. So again, you see here's the curly braces on either side. City name, and you've got your three city names, and then population, and those three numbers. You notice here that there's these numbers 0, 1, and 2, and that's because with a series or a data frame, Pandas automatically indexes those names or values or whatever with numbers from 0 to as high as many values as you have. So now let's go back here and run the cell, and now we see a nicely formatted data frame. So again, this is the spreadsheet kind of view where we have our two columns, city name and population, and then our index 0, 1, and 2. So it's just the number of rows. So even though in this case we've created manually a data frame using a list of names that we type in, normally you're not going to end up doing that. Typically what will happen is we'll read a file containing data already, and we'll parse that, or Pandas will parse it, into a data frame syntax. So here's an example where we're using a URL actually. So this is a CSV file that's hosted online, and you can see we're using the read CSV method. And then notice we're using the method describe on the data frame itself. So first we're using pd.readcsv to load in a file with some data into a data frame, and then we're describing that data with some statistics. So here we're already getting the basic statistics for this data just by using this describe method. Let me go ahead and, so here is how I would normally start exploring a data set. So I'll use this head method, and head is going to print out the first 5 rows. You can see here index 0, 1, 2, 3, 4. So that's the first 5 rows of the data frame. You can see all of the different variables or parameters that are in the data set. And now, again, we can run the describe, and that's where we'll get the main statistics of what's in this data set. All right, so another thing that we can do is graph directly using pandas. So we have this data frame, and we can actually call different plotting methods. So they have different types of methods, but one of them is hist. So we can create a histogram of just the median age of houses in this California data set. There we go. Let's create another example plot here, and let's just do, what can we do that might be interesting? Let's create a scatter plot between the total rooms in a house and the total bedrooms in a house. Those will be correlated, of course, and so that might be an interesting thing to look at. So let's see. First of all, we don't know necessarily how to call this plot function. So let's call our data frame, and then we'll say plot. So look what I'm doing. I'm using a question mark here, data frame, and then using the plot method. And by doing that, I can actually get help on this particular method. So you can see, let's see, so parameters takes X and Y, positions, kind of plot to produce. So we can say a scatter plot. So now let's come back over here, plot, let's say total rooms, total bedrooms, kind equals scatter. And let's see if this works. And it does. Look at there. So total rooms, total bedrooms, we can see the summary statistics here, and then if we wanted to see how they were related. Now this is kind of an interesting plot because obviously this is not the number of bedrooms or the number of rooms, because obviously no house in California, even though they are big, sometimes they're not going to have 20,000 rooms. So this must be something like square footage of the rooms. But either way, you can see we have the scatter plot, it's correlated, and so that's very nice to see. You can access data frame data using familiar Python dict list operations. So for example, we can create a data frame using a dict, and then we can access that a particular column in a data frame using the same type of terminology or the same type of syntax that we would use to access a value in a dictionary. So cities, and then we have these open close brackets, and then our key name. In this case, it's a column name. Let's go ahead and print this out. So we have our cities. We're printing the type of cities. It's a pandas series, as you can see there. So the class of cities city name is a series, and it's a series instead of a data frame because this is just one column in that data frame that we've now accessed. So there's the notebook here has a note that there's a lot of different ways you can index and select data in Python pandas, and there's a lot more information about that if you just click that link. You can also use basic arithmetic with pandas data frames. So we have population. Population is our series, and we can do mathematics for the series. We can use NumPy functions with a series or a data frame. For more complex functions, for things that are more complex than single column transformations, so if you want to write your own function, for example, or in this case, we're applying a logical operator, you can use this apply method. So again, here's our series, and you can use apply, and lambda allows you to define what's called an inline function. So lambda just means that whatever is coming is going to be a function of val, and then you're going to apply that to each row in your series. And so we see here population value greater than 1 million. Only one of those 3 cities that we had in that series has a population greater than 1 million. So this is, again, we want to apply an operation. We want to see which cities are greater than 1 million. So we're going to pass that as a lambda function, and we define it in this way: lambda variable greater than 1 million. And the variable is going to be applied to the series that we pick. You can do things like add, subtract, multiply, divide series in a data frame. You can assign a new column in this using this syntax, where you simply name the new column as if you were doing a dictionary, and then assign to that new column the output from some operation. So let's go ahead and run this. And now you see we've added these new we've added these new columns here where we've simply assigned the area square miles, and then we're calculating using the other columns what the population density is in each of those places. All right, so exercise number 1, modify the cities table by adding a new Boolean column that is true if and only if both of the following are true. The city is named after a saint. The city has an area greater than 50 square miles. Boolean series are combined using the bitwise rather than the traditional Boolean operators. For example, when performing logical AND, use a single AND instead of the text AND. All right, so let's try to do this. I'll just walk you through this, and you can try to do this on your own as well. All right, so cities. Let's have a new column. You usually want to name your columns something which makes sense for what you're doing. Well, let's just come up with something. Saint, cities, plus size. All right, so that'll be our new column name. And we're gonna make that, what are we gonna use here? We're going to see if the city is named after a saint and the city has an area greater than 50 square miles. So first of all, we've got our first 2 cities, San Francisco, San Jose, are named after a saint. And we need to look and see if the area in square miles is greater than 50. So let's do a couple things here. First of all, let's create one Boolean for the first criterion. So named after saint equals, we're just going to say true, true, false. Okay, and then area greater than 50 is equal to, and now here we can use the area in square miles. So let's just copy and paste it, greater than 50. Now notice here I'm just calling this directly. And now we can apply both the criteria and assign those values to this new Boolean column. And then we'll just print that out. All right, so now we have our new column, Saint Cities plus size, false, true, and false. Only San Jose is both greater than 50 square miles and is named after a saint. We can compare our solution with the solution given by in this notebook. And you can see here again, we're assigning a column name. They're naming their column something slightly different, but they have, here's our 2 criteria, our city's area. And now you can see they're using a special Python function here to explicitly, so rather than where we just made a list which said true, true, false, this is a much nicer programmatic way to see if the name begins with San. And so they're applying a function to the city name series, applying that function. It's a lambda function, so lambda name. Name is whatever is coming out of each row of this series. So it'll be each name, San Francisco, San Jose, Sacramento. And then with that name, they're going to say, because this is a string, San Francisco, San Jose, and Sacramento are all string, we'll use this starts with method, which is a method that goes with strings. So they'll say name.starts with San. And so they'll be able to, and there are ways that you could write a function to do this as well if you didn't know that starts with was a method that goes with strings. But either way, they're using this nice function to just programmatically determine whether or not the cities begin with the word San. And then notice that they're taking both of those things, they're putting those together with parentheses, and then here's our ampersand here, which is our logical AND. So if the area is greater than 50 square miles and the city name starts with San, then it's going to be true. Otherwise false. And we can run this here as well. So let's just look at that, and you can see we've gotten the same results. Good. So both series and data frame objects also define an index property that assigns an identifier value to each series or data frame row. Again, this is these 0, 1, 2, 3, 4 that we've looked at. We can print that out or access it by the index method. So we have here our city names data frame, and we can print out the index. It's a range index starting at 0, stopping at 3, and stepping by 1. So it's just going from 0, 1, 2, and 3. Both series and data frames have an index attribute. And so now we've sorted the whole data frame by population. And if you notice, the index is not reordered. it is reordered. It doesn't change, so the original indices are always maintained, and those indices will be shifted around to follow whatever way the rows change. And this is useful if you want to ever get back to the original series, for example. Also, one thing to note is that reindexing is a great way to shuffle or randomize a data frame, and this is useful for certain machine learning applications, for example. So you can pass in the cities.index, so you can pass in the index of the data frame to a permutation function, which just randomly shuffles a set of numbers, and then you can reindex the data frame based on those numbers. All right, and I will let you experiment with this last exercise. So this is a little bit of an introduction to the Pandas data frames. What we'll end up doing oftentimes is loading in data, calling a particular variable and either plotting it or passing that into another function, and so on and so forth. So very useful. Pandas is a very useful package for manipulating large data sets. You can load a large data set into Pandas that won't even load into Microsoft Excel or Google Sheets because it's too large. So it's a very useful utility package to have for looking at data. All right, and with that, I will let you continue kind of experimenting with Pandas. Check out the documentation about indexing and selecting data. Also check out just the Pandas documentation site. I'll just go to that quickly. Getting started, user guide, API reference. The API reference and developer guide are going to be more detailed, but you can just go to the getting started guides and getting started tutorials. So what kind of data does Pandas handle? How do I read and write tabular data? Select a subset of a data frame, creating plots, creating new columns, calculating summary statistics, changing the layout, and so on and so forth. These are all things that we've touched on, but these will give you more details. Okay, so with that, I will finish up and see you in the next video.